Today topic is adhesive force. What is adhesive force? Attraction force between attraction force between different kind of molecules. Understand? Cohesive what is cohesive force? Attraction force between similar kind of molecules. Next, what is wetting fluid? Wetting fluid. What is wetting fluid? Wetting fluids adhesive force greater than cohesive force. A fluid in which adhesive force is greater than an example is water glass interface. You can see the water and glass interface. This is wetting fluid, and for wetting fluid, this is the surface, and this is the water, and draw a tangent and get theta. This is the angle of contact. Suppose this is water droplet. The angle of theta less than 90 degree for wetting fluid. For non-wetting fluid, cohesive force greater than adhesive force in this wetting fluid. The example is mercury and glass interface. An angle of contact. Suppose this is the surface, and you can see when mercury on the floor, the shape is this, and draw a tangent, and this angle is point of contact. So point of contact for non-wetting fluid is greater than 90 degree. Understand? Next topic is capillarity. Capillarity. What is capillarity? Capillarity. It is the phenomenon of. It is the phenomenon of phenomenon. It is the phenomenon of rise or fall of liquid surface to a small tube adjacent to the or relative to adjacent surface adjacent level of liquid when tube is held vertically. Suppose this is a container. It's filled with liquid. This is the small tube held or inserted vertically. Small tube this is small tube for wetting liquid. This is the rise, capillary rise for wetting liquid. This is called meniscus, and this meniscus shape is concave. Same. Suppose this is the liquid. Suppose this is the non-wetting liquid, and a small tube is inserted and this shape is occur, and this is the capillary depression here. And the meniscus is convex. And now tell how to get the capillary rise or capillary depression value. Suppose this value also h. Now suppose this is the draw a tangent on the meniscus on the meniscus at a point. This is theta. This is suppose surface tension. This is the theta is the angle of contact. Angle of contact. This is the angle of contact. Theta. Angle of theta. Theta is the angle made by the tangent drawn on the meniscus at the points with the wall of the tube. With the wall of the capillary tube. Theta. So we can say, and this is also draw tangent. So surface tension. So we can say the force into this force due to surface tension equal to force into surface tension equal to mg of fluid or liquid. Surface tension sigma into L. Always we know the surface tension always acts circumference of free surface. Always acts circumference, and a length is 2 pi r. R is the radius of capillary tube into cos theta equal to mg rho. Area is liquid of area pi r square into area into the height mane rise. This is the volume. This total is volume into G. Now pi cancel out and R. So capillary rise H equal to sigma 2 sigma cos theta by rho G R. So H equal to 4 sigma cos theta by rho G small d. This is the capillary rise. Same case you get this value, in same case not depression. So capillary rise or capillary H is the capillary rise capillary rise or depression. may mm, this this formula is very important for any kind of SSC, even GATE exam or IS exam, capillary. And T is the dia of capillary tube, and rho is the density of liquid, understand. Now for pure water, there are 3 points: pure water and glass, angle of contact is 0, but for water and glass, theta is 29 degree. 3 number for Hg and glass, angle of contact equal to 128 degree. Now what is viscosity? It is the property of fluid. It is the property of fluid which offers resistance to the movement of one layer over another adjacent layer of fluids. It's called viscosity. Now, reason of viscosity. This is very important. Reason of viscosity. One number is because of cohesive force. This one is for liquid. Number 2 is intermolecular momentum transfer. This one for gas. Cohesive force for gas greater than cohesive force of liquid. When temperature is rise, now For particular molecules of gas have a mass and velocity and give momentum, and after collision give momentum transfer. And the viscous for frictional force due to the frictional force generate viscous effects in gas. This is the intermolecular heat transfer, intermolecular momentum transfer. Suppose this is solid boundary or solid plate. This is the solid plate. This is the solid plate. Liquid is flowing. Flowing. When liquid is contact with the solid boundary or this solid plates is adhered to this and here this is the velocity of flow, velocity of fluid, velocity of fluid is denoted by V, and here velocity is 0. There is no slip condition, and the perpendicular distance y, the distance perpendicular the solid boundary y, and here free stream velocity, u equal to u infinite. There is, and here in this region there is a velocity gradient exists. Here du not equal to 0 in this region. After this region velocity gradient is 0, and the velocity profile, this is the distance perpendicular to the solid boundary, and this is the solid boundary.